So this is section 14.2, if you like to label your notes. It's the second section in our rational functions. And what it is now that we know what a rational function is and we know how to simplify them, we're going to start doing stuff like adding, subtracting, multiplying, and dividing. When it comes to fractions, though, multiplication and division are easier than adding and subtracting, so that's why it's first, okay? So how are we going to multiply and divide these things? Basically, it's what we just did in the first section today, except for you have two numerators to factor and two denominators to factor. But if anything on top can cancel out with anything on the bottom, we're good to go, okay? And that's all it says. It says, in order to multiply, just completely factor each of the numerators and denominators, multiply the numerators and multiply the denominators, and simply write the product in lowest terms by dividing out common factors. You can divide out common factors before you do step number 2 if you want, okay? And then how do we divide? If you remember way long time ago when you had to do division with fractions, you actually multiply by, they call it the reciprocal, just the flip. And then it's a multiplication problem, okay? So let's look at this one first. We have 25x over 2 times 1 over y to the third. Do you guys agree that neither of those numerators and neither of those denominators cancel? Nothing cancels. And so what you do is, even after you cancel, you always just multiply straight across the top, straight across the bottom. So this answer is 25x times 1, or 25x, over 2 times y to the third, or 2y to the third. Wouldn't that be great if all your problems were just like this? Just straight across the top. What's 25x times 1? 25x. What's 2 times y to the third? 2y to the third. Okay? On the second one, though, what I'm going to do, you can either cancel out at the end or at the beginning. I like to do it at the beginning before my numbers get too large, okay? Do you guys notice that you have a 7 up here, but then a 14 down there? Okay? So how many times does 7 go into 14?
Once.
Twice, right?
Twice, yeah.
Well, once into itself. So 7 will change to a 1, and this will change to a 2. Is that okay? What about the x squareds? They cancel out completely, don't they? You see how you have two x's up here and then two x's down here? They don't have to be directly over each other. They just have to be on opposite levels. Because how we could write this, I'll show you 2 ways to do it, but I think this way is easier, and I'll show you at the end how it all works out. Then you go to the 3. Does the 3 cancel out with the 5 or the 2? No. But what about the y's? You have 5 y's on top and 1 y on the bottom. What can happen with the y's?
It's turned to 4y.
Exactly. So I call it, it's like a boxing match, basically. That y on the bottom can knock out one of the y's up top, but he still has 4 remaining. So he disappears and he changes to y to the 4th. I think these are harder than the ones we have to factor on. Okay. After you cancel everything, you just multiply straight across. So what do we have? We have a negative 1 times a 3, which is a negative 3, and a y to the 4th. And what do we have on the bottom, guys? We just have what? Or the 5. Don't forget about him over here. So the 5 times 2, or the 10. How else could you have done this? I'm going to write a big or over here, and you don't have to do it. You can just follow along. You could have multiplied straight from the beginning, okay? What's negative 7 times 3? Negative 21. What's x squared times y to the 5th? X squared y to the 5th. All over 5 times 14. I don't know what 5 times 14. I think it's 70. And then x squared y, like that. So you could multiply from the very beginning, but then you have to reduce. And so you say, okay, what do 21 and 70 reduce to? 3 and 10. The x squared would cancel out, you know what I mean? I think it's easier to do it in the front half, the beginning part, because the numbers are a lot smaller and easier to deal with.
It doesn't matter if there's an x or a y behind the number?
Nope.
Nope.
Nope, because it's multiplication. If there's a plus there, it will make a difference. All right. So these we're going to start doing a little bit of work, because these are just single little terms, but these are called binomials when you have 2 terms and a plus or minus in there. So what I'm going to do is I'm going to rewrite this by factoring, okay? So this first one, what can I factor out of that top? What comes out of x to the squared plus x? What do they have in common? X, okay? And when you factor out the x, what are you left with?
X plus 1.
Perfect. And the bottom is just going to be a 3x. Is that all right? times 6 is going to stay 6, but what can I take out of 5x plus 5?
5.
You got it. And what's going to remain? X plus 1. And you're going to just see things like that happen. So what you do is you start with that x on top, and you ask yourself, is there a single x down here that it can cancel out with? There is. Do you see that single x right behind the 3? So this x can cancel out with this x. What about this x plus 1? Is there a quantity x plus 1 on the bottom that it can cancel with? It can, because it doesn't have to be right over itself, right? So this x plus 1 will cancel out with that x plus 1. As long as they're on different levels. It can be right under it or catty corner. All right, what about this 6? What can cancel out with the 6?
3.
And the 3 goes into 6 how many times? Twice. Okay? So when you do all of that, guys, what's the only thing that remains up top?
2.
Yep. And what's the only thing that remains on the bottom?
5.
Yep. So what's crazy is this fraction times this fraction, the answer is 2/5. It's crazy that you have all those variables, but all those variables end up canceling out. And it just multiplied to be 2/5. All right, they're just going to get a little bit more complicated in the fact that you just have a little more work when it comes to factoring, but the concept's the same. Factor each of the numerators, factor each of the denominators, and cancel out anything on top with anything on the bottom. So this first numerator, this first numerator, what can we take out of 3x plus 3?
3.
A 3, you got it. What is that going to leave us with?
X plus...
How do we show the 3 was there? A 1, yep. What can you take out of that denominator?
5.
A 5 and then x. And what's that leave you with? 1 minus x? Does that look okay so far? Notice so far we can't cancel out anything, but that's going to be pretty common. I think a lot of times you're going to be canceling out with the other numerator and the other denominator. All right. How are we going to factor this? What do we have to do? The AC method. Again, for purposes of just getting through this section relatively quickly, I'm not going to actually do the AC method. I'll just make the little rainbow and note so you know how did we get from here to here. What are factors of -6 that add up to 1? A positive 3, a negative 2. You rewrite your middle term that way, blah, 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 okay? What does that factor to? 2x plus 3 times x minus 1. All right? On the bottom, guys, how does he factor? He's not a trinomial, so we can't use the AC method, but what is he? He's a special guy. Yes, and you even have the right terms. Difference of squares, right? 4 and x squared are perfect squared, and 9 is a perfect square. So how are those going to factor? Remember, you just put the square root in front, the square root of the back, and do opposite signs. So how does 4x squared split up into a perfect square?
2x.
Yep. And then 9 will be 3, and then opposite signs, and it doesn't matter how you have them. All right, so notice it's exactly what we did all of chapter 13. It's just that instead of factoring one ugly thing, you get to factor 4 of them now, okay? So once you have them all factored, you go one by one. Is there just a single 3 down here? No, the only 3s are here, and they're not a single 3. They're with that 2x plus 3, so he's not going to cancel out. Is there a single x plus 1 down here? No, so he's not going to cancel out. Is there a 2x plus 3? Yes, they're going to go. And then what about the x minus 1 and the 1 minus x? The negative 1. It's that difference of a sign, okay? They're just flip-flop with the opposite sign, so I'm going to just go like this and just remind myself the answer is going to be a negative. Once you do the entire top, guys, know that there's going to be nothing left on the bottom to kind of cancel out. So you just multiply everything that remains. We have a 3, we have an x plus 1, and we have a negative 1. So it's just going to be a negative answer.
Can we rewrite it with all of the things we crossed out? Like 3x plus 1 times negative 1.
Yes. Okay, so before you do the final answer, yeah. So what she's saying, she wants to kind of like clean it up with what remains, like that. Is that what you're talking about, Anna? Okay. And then realize that we don't ever really write it with that minus 1 like that. When you multiply by a negative 1, what happens? It just changes your sign. So your final answer is just negative 3 times x plus 1 all over 5x times 2x minus 3. You guys see what we did there? So we canceled out everything they had in common. But when we cancel out that x minus 1 with the 1 minus x, it was that difference of a sign, which made our answer end up being a negative there. Okay? Guys, Division, exact same idea, except for we're going to change the division sign to multiplication, and you flip only the second fraction, okay? So the first fraction is going to stay 3x cubed y to the 7th over 40, but then I'm going to write times y squared over 4x cubed. So the front fraction stays as is, the division symbol changes to a multiplication symbol, and you flip the second guy, okay? So is there any number that can cancel out with a 3 down here? No, 40 and 4 can't cancel out with a 3. What about the x cubed? Can it cancel out with anything?
Yes.
Yep, and actually perfectly, right? They won't always have to be perfect. Like you could have x cubed next to the 5th and kind of talk about what happens. All right, y to the 7th. Notice there's y to the 2nd, but where are they both located? They're both located on the top, so they don't cancel out. So the only thing that ended up canceling out, guys, was our x to the 3rd. So what we're going to do is we're going to multiply what remains. Well, we have a 3, and then how many y's? Say it louder, I think I heard it. 9, is that okay? Over 4 times 40, which just happens to be a giant number, 160, but none of it canceled out, so it's not going to cancel out now. You see what we did? So y to the 7th times y to the 2nd, we just add the new, or the exponents. All right, over here, I'm going to do the same thing. As I rewrite it, I'm going to kind of factor it. So do you remember what it means when you have a quantity squared? It means that times itself, okay? So technically, this factors to x plus 2 times x plus 2 all over 10. Is that okay? X plus 2 squared is just it times itself. Then what am I going to do with that division symbol? I'm going to change it to multiplication, and I'm going to flip this guy. So the 5 is now going to be on the top. And if you guys are okay with it, instead of writing 2x plus 4, I'm going to write it in its factored form. What can I take out of 2x plus 4?
2.
A 2, and that will leave me with x plus 2. Does that look right? All right. Once you have it rewritten as a multiplication problem and everything's factored, then you just start canceling what you can, okay? So do you guys agree that one of these will cancel out with him, but that's about it? And what will this 5 cancel out with?
5, 10, so 1.
Yeah, so he'll go to a 1 and he'll go to a 2. And that's it, right, as far as canceling goes? At that point, we want to clean it up by just multiplying. We have an x plus 2 times a 1, or that's x plus 2. And then 2 times 2 is 4. I want to point out to this, oopsie, I'm going to throw away my pencil. At this point, guys, you can't cancel. So as much as you're like, okay, that 2 and that 4, it should cancel out, is that really a 2? No, that could be a 5. Like if I said, no, guys, x is 3, what is the top number? 5 over 4. So it's not really a 2, it's just 2 more than whatever x is. And so that can't cancel. Don't think of it as 2. Think of x plus 2 belonging to each other, so you can't cancel those out. So we're just going to be done at that point. You can only cancel them out when they're like right next to each other, multiplied, not if there's a plus or a minus in between them. All right, guys, we're just doing the same thing. When I rewrite it, I'm going to factor it, okay? So looking at 6x plus 2, what can I factor out? I feel like there's just a lot of GCF ones. Yeah, 2. Yeah, it's just a lot of GCF. So this is 2. But when I factor out a 2, what's 6 divided by 2? 3. So I'll have a 3x plus 1. Is that okay for that part? All over, let's go ahead and factor x squared minus 1. That's a difference of squares. So how is that difference of squares going to factor?
X plus 1.
Beautiful. So we rewrote the first fraction as completely factored. We could take a GCF out of 2 from the top, and we could do the difference of squares. Since it's division, this is going to change to multiplication, and this denominator of x minus 1 is going to pop up top, okay? And then as I rewrite this new denominator, what can we take out of 3x squared plus x? And x. And if you guys want to factor up here first, that's fine. Like if it's too much to factor it 3 steps lower, you know, it's kind of hard. Okay, I take out an x, what's that going to leave you with?
3x.
Perfect. And at that point, you see everything that happens, okay? Is there a single 2 down there on the bottom that can cancel out with that 2? No. But is there a quantity 3x plus 1 we can cancel out? Yes. Is there a quantity x minus 1 we can cancel out? Yes. And so once you cancel out all the common terms, you multiply what remains. What's the only thing that remains up top? Just the 2, right? Because we said this 3x plus 1 canceled out with this 3x plus 1. That x minus 1 canceled. So we're left with a 2 on top. And then down here, do you guys see the x plus 1 and the x? It doesn't matter what order you write it, but typically you write your single things in front just so you don't lose them, okay? So that's x times x plus 1. What's nice is they don't want you to distribute, okay? So even though you could write x squared plus x down there, they don't want you to do it, and I say don't do it because you end up making mistakes when you know you don't need to even be doing it, so don't worry about that. You guys are doing awesome. All right, this is the same idea, but they're just going to change how you have to factor. So since this is a trinomial, guess what we're going to have to do? The AC method, okay? So what are factors of 10 that add up to negative 11? 10 and 1. So again, if we had time and we had space, we would rewrite this as 2x squared minus 10x minus 1x minus 10. We would do factor by grouping. But just for purposes of saving time, this factors to 2x minus 1 times x minus 5. On the bottom, since it's just a binomial, we can't use the AC method, and I think you guys are going to see a lot of just GCFs. What can you take out of 5x and 25? A 5. So that leaves you with x minus 5. Does that look okay? Since it's division, what are we going to do? Change it to multiplication and flip. The 10 that was on the bottom is now a 10 on top. And what can you take out of 4x minus 2? What do they share? A 2. So the 4 divided by 2 leaves you with a 2x minus 1. Does that look good? So the first numerator was AC method. The first denominator was just GCF. And then when we changed it, the next numerator, we didn't do anything. It's just a 10. And the second denominator is just a GCF. So 2x minus 1 is going to cancel. Is that okay? X minus 5 is going to cancel. Oh gosh, there's a lot going on here. Okay. The 10, do you want to cancel him with a 5 or 2? It doesn't matter. What do you see first? The 2, okay. So the 10 will go down to a 5 and the 2 goes to a 1. Is that right? But then what do you notice about this 5 and that 5? They cancel as well. Or say you don't notice it and you're like, okay, what remains on top, what remains on bottom? 5 over 5, right? What's that reduced to? 1. Guys, when it's all said and done, how do you take one fraction and divide by another fraction? Your answer is 1. They're the same fractions. So this was just a simplified version of this fraction. So when you took this divided by that, it cancels out to be 1. So we do all these hard ones, and then we get to this guy who's not bad at all. It's multiplication, so we don't need to flip anything. Everything's already kind of factored. What's going to happen on this one? It's just going to be x over 5. Why? Because the x minus 4s are going to cancel. And what remains on top is x. What remains on the bottom is 5. Then what they do on the bottom left corner is they give you the exact same fractions. X minus 4 over 5, but now it's divided by x over x minus 4. So they want to show you what happens, okay? So x minus 4 over 5 stays x minus 4 over 5, okay? But the division changes to multiplication, and then this changes to x minus 4 over x. Is that Does anything cancel out? No. So remember, this x is not really an x. That's x take away 4, okay? So this could be 9. So that's like 9 minus 4 is 5 over 9. It doesn't cancel. So what you do is you just multiply straight across. But what do you get when you take x minus 4 times x minus 4? You can write it as x minus 4 squared. All right? And on the bottom, what are we left with? 5x. All right, so this last one, basically has everything going on. It has a difference of squares, it has an AC method, it has a GCF, and it has a difference by a sign. So like, the only thing it's missing is making it a division problem, basically, okay? So we go to factor this first guy. How's x squared minus 4 going to factor? It's a difference of squares, right? So that will be x plus 2 times x minus 2. On the bottom, we can take out a 2, and that will leave you within x plus 3. So that first fraction is completely factored, all right? So we're going to move on to the second one, where we would have to use the AC method. So we'd have to think of factors of 3 that add up to 4. What's the only way 3 splits up? 1 and 3. So you would rewrite this using x squared plus 3x plus 1x plus 3, you know, all that stuff. This factors, guys, to x plus 1, x plus 3, and then just leave him as a 2 minus x. We'll take care of him in a second. Alright, so we completely factored everything, so now it's just a matter of canceling out what we can. X plus 2, does he cancel out with anything? No. What about the x minus 2? Yes, but when we do it, what do we have to make sure we put? The negative 1 up there, right? What about the x plus 1? Nope. What about the x plus 3? Yes. So what remains up top, I'm kind of running out of room, I'm sorry, is a negative x plus 2 times x plus 1. The negative, because the x minus 2 and the 2 minus x just differ by that sign, so my answer is negative. And then x plus 2 and x plus 1. And then what's the only thing on the bottom? 2. Yay! Okay, since you guys are rock stars, I'm going to go ahead and finish these notes, but we're not going to even touch the worksheet till Wednesday. It'll be a good review of what the heck did we learn today, okay? And the homework won't be due until a week from Wednesday as well, since we have kind of double stuff going on. So do you guys, again, I kind of sound like I'm repeating myself, but that's going to be due. We're going to work on that. We still have 20 minutes, so we'll work on that at the end, okay? It is just factoring over and over again. And so this is why I kind of tried to stress the importance of factoring. So on the back, it's just like, why do we need to know to multiply by rationals? Like, what's the big deal? Well, you actually multiply by rationals when you convert from inches to feet and all that kind of stuff. So you guys have already learned this at some point, that 1 foot has 12 inches in it, 1 yard has 3 feet, 1 mile has 5,280 feet. And you've converted from feet to inches and so forth, but you've never had to do square feet to square yards. Well, the only difference is that we're going to square not only our unit, but our conversions, okay? So when we say we have 1 foot to 12 inches, we're going to say we have 1 square foot to 144 square inches, okay? So start with what you have, 18 square feet times our conversion, okay? 18 square feet times our conversion. What do we want to change to? We want to change to yards, so he'll go up on top, so we'll have square yards down here, or up here. And what we want to get rid of, square feet, will be on the bottom. Because remember, we like to cancel, and how do we cancel? We cancel the top with the bottom. So start with what they give you, 18 square feet. And then what you want to convert to, he goes on top, so the yard goes on top. And then you just use this unit. You have 3 feet in 1 yard, so you have 3 square feet in 1 square yard. And that's the only difference, guys. Instead of just multiplying or dividing by 3, you're going to multiply or divide by 3 squared, okay? So what happens? Our square feet cancel out, and we're left with square yards. Yay. But this ends up being 18 square yards over 9. So what do we still need to do? What do we do there? What's 18 divided by 9? Wait, say it louder? 2. And that's your answer. 2 square yards. So that's the only difference. Instead of like using 12 inches, you'll use 12 squared inches. And so you'll have 144 there. Let's look at this one. So we have 5.2 square yards What we want to get rid of, square yards, goes on the bottom. What we want to go to, square feet, he goes on top. And then you just come up here to your conversion. 1 yard goes to 3 feet, so that's why we put them where they are. But it's squared, so it's 1 squared yard goes to 3 squared feet. At that point, you ask yourself, what's going to cancel? Square yards. So you're left with 5.2 times 9 square feet. You guys see what I'm doing? I'm just multiplying straight across. 5.2 times 3 squared, which is 9. Just throw that on your calculator. What is that? 46.8 is what I have. Does that sound right? So like if you had to convert carpeting or something, you would be able to convert the yards to the feet. All right, last thing is volume. Volume is cubic. So guess what we do? Instead of squaring, we cube. That's the only difference, okay? So we have a large building in Boeing in Washington has these jetliners that they got to fit. The volume is 472,370,319 cubic feet. And they want us to convert that to cubic yards. So my cubic feet will go on bottom because that's what I want to cancel out. Cubic yard will go on top. And all I do, guys, is go and grab that unit. Remember, was it 3 feet to 1 yard? But since it's cubic, it's 3 cubic feet to 1 cubic yard. So we're just going to cube that. What is 3 cubed? I think we have that memorized at this point. 27, right? So our cubic feet are going to cancel out. The cubic yard's going to remain. 1 cubed's 1, so I don't really care. So guys, ultimately you get this 472 million number divided by the 27. So what does that end up being in cubic yards? You see what I'm doing there? So the cubic feet cancel out. The 3 cubed doesn't, okay? So that's just 27. So straight across is the 4 million number. Straight on the bottom is the 27. It's still a huge number. I have, see if this matches what you have, 17,495,197 cubic yards. Does that sound right? Is that what you got when you took that 4 million number divided by 27? 17,495,000.
Yes.
Is that sound right? Isn't that, it's still huge. Like I can't fathom the size of these. It blows my mind, these complexes. If anybody drives 255 and see those Amazon complexes off the side of 255, exactly, and I'm like, every day I drive by it, and I'm just watching how they're putting up like these cement walls, basically, just with cranes. And I'm like, how are they getting those to stand? Because that makes me really nervous. All right, this last one, guys, is just kind of for fun. I don't know if any of you guys are like track and field. I was never a track and field person, but I always like watching it in the Olympics. But Usain Bolt's one of like the fastest guys in the world, and he can run the 100-meter dash in track in 33.9, actually it's an average of 33.9 feet per second. So we can convert this to miles. I'm going to do it really quickly. If you don't catch all of it, that's okay. It's just kind of more for fun to see how fast he is if he's riding around campus. So you start with his, which was 33.9 feet over 1 second. That's how you can write feet per second. Times, well, I don't want feet, I want miles, okay? So since I want to get rid of my feet, the feet go on the bottom and the miles go on top. And you just grab that conversion from up top. So there's 5,280 feet to 1 mile. Okay? So all we've done with that one conversion is just converted feet to miles. I still need to change my seconds to hours. So he's way down here, but he's on the bottom. So if I want to get rid of him, he needs to be at the top. And I want to change it to minutes because he's my middleman. I'm doing like 8 conversions in one, okay? I don't want minutes though, so he's going to go up top. And I want hours. And we'll change all those, okay? If you know how to convert seconds to hours like that, you can. But let's see if all of our like tags or units cancel out, okay? So the feet's going to cancel out, which is good. The miles won't, which is good because we want miles per hour, so we want miles on top. The seconds will eventually cancel out because we have seconds on the bottom and seconds on the top. And the minutes will eventually cancel out because we have minutes on the bottom and minutes on the top. And notice we have the hour on the bottom. So we're going to have miles per hour at the end. But how many seconds? There's 60 seconds in 1 minute. Is that okay? And then there's 60 minutes in 1 hour. So at this point, guys, it's just straight multiplying the numbers on top and multiplying the numbers on the bottom. So we're going to take the 33.9 times the 60 times the 60. And then the 5280 is the only thing on the bottom. What do you get when you multiply those? Is it a weird number, Anna, or no?
122,040.
Okay. And we're going to divide that by 5280. Will you take that and divide by 5280 and see what you get? Round it to 1 decimal place.
23.1.
And what's our unit? Miles per hour, right?